Welcome to Regents Physics Warm Up. Feel the heat? This is a 7-part series in preparation for the Physical Setting Physics Regents Examination. I, your host, Mr. B, will lead you through not memorization, but process skills. There are many processes involved in completing the Regents Examination successfully, so let this warm you up, both before you're studying and right before the test. Our first video episode today will be Part 2. Tools in ready position. As with all parts of this review, follow these steps both during practice and during the examination. It is not practice that makes perfect, but it is perfect practice that leads to perfect examecution. All right, let's go. So, a few basic things here. Calculator always gives the right answer. Yeah, as long as you're in degree mode. Ooh, let's go back to degree mode. Who's that over there peeking out through the... Oh, that's a little calculator. Look at that nice little calculator. You see degree? Put it in degree mode. See a calculator. Set your graph to zoom standard. Here's a simple one. When dividing by a product, make sure that you actually have that product in parentheses. These two are not equal to each other. Pump them into your calculator and confirm. Also, do not use the letter E in your write-up. Always write times 10 to them. Well, a ruler always gives you the right answer, right? Yes, as long as you use it correctly. So, here is your protractor ruler. Some of you will just have a ruler that looks like this segment here with a separate protractor. But some of these actually have mm written there, and some of them have cm written there. So what are these 1, 2, 3, 4, 5, millimeters or centimeters? Well, let your little pinky tell you. Bring your finger up. Your pinky is approximately the width of 1 centimeter. So if your pinky covers approximately the gap from 1 to 2, or 2 to 3, or 3 to 4, those are centimeters. Rock out, pinky. Next, the protractor always gives you the right answer, right? Well, you better line it up. You get 2-degree margin of error. So you need to line this up just right. Okay, come on down here. Talk to the hand. Here we go. Here's your protractor, and there's a setup you might see on the assessment. You might see here's a boundary line, and you might see a normal line. You may even see a ray. And you must bring your protractor and line it up perfectly. Obviously now it is not lined up. So we do a little rotation to get it lined up. There's a black line that runs along your protractor. You can see it here. Now they're different on different protractors in different locations, different gaps, but they all have the line somewhere. So you need to get that line exactly along the boundary that you're trying to measure. So a little wiggle. And then they all have a crosshair. Crosshair is right here, although I'm going to move that in a moment. That should be right at the point of intersection, the point where you need to measure, right about there. Okay. Now, if you notice, another problem that tends to come up, we want to measure the angle right here. However, this ray, or this little red segment, does not quite reach out. You don't need to guess. Don't approximate. In fact, what you can do is take your protractor, flip it around, use it as a straight edge, and extend your line. No shortcuts during this assessment. Extend your line. Something as follows. And then, when you bring your protractor back around, this will be much easier to actually get an accurate measurement. Notice all the time I'm taking to line this up, you should take at least that much time. And once you have it lined up, make sure that you hold everything firmly. Even there, a little bit off still. Okay, right around There is pretty good. All right. So we have everything lined up, and we are now in position to actually measure this angle. We can see exactly where it crosses on the protractor. Now, additionally, with using your protractor, you need to count. Protractors have two sets of numbers, so no matter where your line goes, it will cross through a minimum of two different numbers. Additionally, sometimes neither of those two numbers are correct. So the recommendation is do what you've been good at since you were little boys and girls. Count. Here's a problem you might find in the exam. Now this is a refraction problem. Your boundary is here, and your normal line is here. Notice this is rotated from how you typically look at these problems. Here's a protractor, a little different than the one above, but maybe yours looks like this. So no matter how you hold this, they're asking you to measure the angle of refraction. That turns out to be this angle right here. More than one way to skin this cat. Line everything up. So if I line up, here's the point of intersection. If I line up my crosshair, have everything nice and perpendicular, I might want to say, oh, it's about 55, 56, or maybe 124, 125. You know what? Don't guess. Count. Count by tens. So over here is 0, 10, 20, 30, 40, 50, about 55 and a half. Good. If instead I hold the protractor this way, it does not change anything. Line it up and count. I started my counting down here, change colors, and it doesn't matter what number it goes through. Play the same game. 10, 20, 30, 40, 50, about 55 and a half, 56. You get the same answer. Okay, so, yay. You're done with part 2. Congratulations. We hope to see you during part 3 of our video series, Regents Physics Warm-Up.